A while ago, I was thinking about like some problems around like why is Filecoin so hard to use, uh, and also why it's so hard to scale things like S3. I think I was thinking more about the scaling aspect than the UX aspect, and I was thinking about it for a while, and eventually I had a whole like string of ideas and came up with this special fancy BlockStore that in theory should both scale and it should also provide really good, really nice UX. So I would like quickly recap how storage in the IPFS and the Filecoin universe works. So in IPFS, when you add a file, you chunk it into some fixed size pieces, usually by default 256 kilobytes. Then you get those chunks into what we call DAC protobuf, which is just a glorified protobuf that can link to other protobufs using CIDs. And when you construct the protobuf, we hash it, we put this hash into a multi-hash, just a fancy way to express hashes with different algorithms. And then we put the multi-hash into a CID, which is the way to express a link to data with some like certain encoding. And this makes it possible to then know how to interpret that data to like further traverse the DAG or the direct acyclic graph. But by default, all the links are linking to DAG protobuf sets. And so for a file, it's just a nice, by default, balanced tree of DAG protobufs. For directories, we just get another like DAG protobuf object per directory. Unless the directory is really large, you get hands, but it doesn't really matter here. And then we put those objects into what we call a BlockStore, which is just a glorified key value store for like mapping sets to the actual block data. Then we can also put those DAGs into what we call car files, which is just a way to store an IPLD graph or a DAG on disk in a file. That's important because Filecoin uses those car files a lot. So storage in Filecoin, you have the Filecoin chain, and it's run by storage providers. Each storage provider is essentially just storing a set of sectors, and a sector is just on mainnet either 32 or 64 gigabyte block of data. And you can then, like, as a client, store what we call deals with miners, and deals are just pieces of like power of two sized pieces of data that then like are stored within a sector, and they can be smaller than the sector. They cannot be too small because that's very expensive. So you kind of have to make your deals like probably at least 4 gigabytes in size for them to make economic sense. And they cannot be too big because we cannot really split deals across sectors yet. So you kind of need to worry about this size. That is really annoying. So if your file is just the right size, that's actually fine. Just create a car file, from your file and you make a deal with some search providers. But even if files are too small, you need to gather a set of files and put them into like one car file that's an aggregate, and then you need to worry about the sizing and so on. Similar with if your file is too big, you need to either split your file up before creating the IPFS tags, or you need to split the IPFS or IPLD DAG after you've created the file, which is also not really that easy or cheap to do. So yeah, aggregating data is kind of hard. You cannot really easily tell what size some DAG will have just by looking at the root node of it. You need to traverse the whole DAG. Then there are like some caveats. So multiple different DAGs that you are aggregating can share blocks. And that makes the sizing really, really annoying because you don't really know beforehand what DAGs you're going to be aggregating. And yeah, like in some cases, you can have, you may be dealing with graphs that are just like a lot of small blocks that are very expensive to traverse, like really deep. And so you need to like really think about how you structure code in a way that it actually works. Then splitting data is also not easy. We have many blocks. Kind of run into similar problems like with aggregation. Just you happen to have more data. And yeah, like just going through really large graphs is just hard and painful and slow. And another problem with the current way of doing things is that usually when you create a car file, you probably are doing that from a BlockStore. Not BlockStore, just a KV store usually. And each time you create a car file, you're doing like tens of thousands to millions of reads per car file, depending on how big your IPLD blocks are on average. And that is very expensive, especially if you want to do like multiple replicas of your files, and like do that a lot and scale it up. Like doing millions of reads probably per second is not easy. So I was like thinking, can we solve all of those problems all at once? Seems maybe hard, but like what if there was a way so that like we didn't have to deal with splitting this data, we didn't have to deal with aggregating it, like didn't have to deal with BlockStore load when you try to build those car files for deals, or like didn't even have to worry about having the DAGs be traversable, and still somehow be able to retrieve this data after deals are made, just with PrefSync or BitSwap. So apparently all the indexes at all layers really only care about multi-hashes, not zits. And there is this like one very special IPLD codec that is called raw, and basically just raw bytes. The raw blocks cannot have links. So what if we just pretend that all the blocks that we're storing are raw and just build some very light DAG on top of those raw blocks that we're storing that are not really raw? Like this light DAG just makes it possible to have the other parts of the Filecoin like deal storage machinery work, like deal indexing and stuff. So that was the core idea behind RIPs, and eventually this derived this architecture. So essentially, like the core part is like there is a top level index and those groups. Groups are just like each group is just a bunch of IPLD blocks that are put into this BlockStore. There is a set of groups that are currently being written to. And then there is just a bunch of groups that are laying around like full and being put on Filecoin probably. And groups can also be offloaded fully. So we're not storing them locally. They're just like somewhere stored with some storage providers. Each group is just deal size to put us somewhere between a couple thousand to a couple million blocks. So it's small, like it's kind of cheap to keep indexed locally, but also big enough to manage all the higher level indexes very easily. And then they're also very easy to scale. Like in the system, there's like a lot of weird looking decisions. But really the aim is that it should be like fully scalable and pretty much linear way. So they started this Kubo node, and this is a normal Kubo node, but it brings two weird lines. It gives me a wallet and gives me another web interface. So if I go to this interface, it shows me a wallet, some balance, this like groups thing, and some kind of piece. So now I can like try to just use this Kubo node as Kubo. So let's say I want to add some like Arch Linux mirror to it, and it's doing some things, just adding it. Right, take a second or two. And the speed is mostly bottlenecked by my disk speed. Could probably be somewhat faster because some indexes are not very optimized or not optimized at all currently. But it creates some groups that build some virtual overlay R file on top of it, computes comp. It does its best to make Filecoin deals with it. Like really nice because I really just typed in 2 commands and sent one field to some address, and it's just storing data on Filecoin. I think it's kind of cool. And so, yeah, like essentially what's happening here is when I do IPFS add, I have a special Kubo node that is running a plugin that is injecting this RIPs BlockStore instead of the default Kubo BlockStore. And so all the writes and also all the reads are redirected to this RIPs BlockStore. I can at least make mad attempts at being the content. Do like the object stat and things, can see some gets happen. When I do that, then it's just a BlockStore really, but it happens to store data in a manner that's really efficient for making Filecoin deals, and also happens to make Filecoin deals. And also, at least on paper, should scale really well. That part I didn't test, and I'm pretty sure that it needs a lot of work to scale. But there's some potential. So yeah, that's my weekend project, I guess.